Good morning, everybody. Welcome to the webinar this morning. We're going to do a quick introduction just to set the scene of the Carbon Trust and the webinar. And we'll look at the what would be a typical energy split for a commercial kitchen. And we'll then go through some of the kitchen equipment, the opportunities that you can find there, and then the wider kitchen services. So that would be the likes of the ventilation, then the cooling and the refrigeration. Then we'll look at the energy management and behaviour, the aspects that are of that are impactful in how the kitchen is run and how the staff behaviour has an impact on it as well. And then there's a couple of useful checklists that we can take a run through as well. That'll be helpful. So just a little about the Carbon Trust. I'm sure you all know that we're a not-for-profit organisation, and our mission is to accelerate the move to a sustainable and low-carbon economy. The three pillars holding up that mission are our offerings, which is advice to businesses and governments on the opportunity in the low carbon world. We also offer footprinting services to organizations, and we also help to develop and deploy low carbon technologies and solutions. And just the wider Carbon Trust work that we've been doing, this is just a quick recent summary of the last 250 audits that we've done. So it gives an indication of all the areas that we would be involved in, and I've highlighted there the significant work actually that we've done with the leisure and hospitality. So we've gotten some good ideas from that work that's going to feed into the webinar today. So while the energy use in a commercial kitchen or wider catering facilities account for somewhere between the 4 and 6%, but that has to be taken in the context with the kind of profit margins that these organizations are working with. So it is well worth spending the effort to improve the energy efficiency of how you prepare and cook food. The wider reasons for engaging in energy efficiency is, as I said, improved margins, but there's also a significant opportunity to improve the kitchen environment. I'm sure we all know that they can be hot places to work and can be quite noisy. There's improved environmental credentials in a time when consumers are being particularly careful about where they eat and what they eat. There is that opportunity to distinguish yourself from competitors by showing and highlighting the improvements that you're making to the business, and that then there is an aspect of reputational improvement then as well. So we're going to look at the three main areas. So we're going to look at the catering apparatus. So that's going to be the equipment that you use to cook and wash, the refrigeration, ventilation as well. The wider kind of building services then in the kitchen, as I said, the ventilation, heating, lighting, and there's also the wider opportunities around the improved energy management and the people solutions as well. So take a quick look at the typical energy split. Obviously, most of the energy is going to be in is going to be the electricity, which makes up about 60%, and the rest is going to be your natural gas for heating and cooking. And the larger loads that you can see, of course, no surprises there with the cooking and the refrigeration and water heating all having a significant impact. So what we've tried to do here is to give a representational view on a variety of typical equipment that you would have in a commercial kitchen. It's not an exhaustive list, but it does give you a good idea as to the areas you should be looking into. The warm-up times are very important. Often the guys come in the kitchen first thing in the morning, switch everything on, and then it stays on. Now, partly that's just because they don't know, or because that's what they've always done. But being able to get and understand what the warm-up time of a particular piece of equipment is can lead to some significant savings. We try to represent then what the typical on power would be in standby power, so it's the third column, and then just a kind of ready reckoner as to how much a typical use of that equipment is over a day and then over the course of a year. So obviously with the carvery decks, then you have these are extensively used. Goes without saying that at the end of the serving, switch the things off. Make sure that the temperature settings for the hot cupboards are as they should be. Don't believe in the doors. Just all these things aren't complicated to do. And again, you can see there by just switching it off an hour earlier has got a major impact on the annual consumption. Similar common sense with the dishwasher as well. Don't be using it unless the tray is full. Then the likes of the salamander has got quite a quick heat up times, similarly with the bain marie, so you can switch them on close to when the serving is going to happen. Fryers are a significant energy user. You can, it's reasonable to turn those down to the 130 mark. It not only saves you energy, but it saves the oil life as well, and the recovery time for it to get back up to a suitable temperature. I mean, it's not overly prohibitive. Similarly, then with the likes of the combi oven, there are some energy efficiency aspects of those that you should look out for if you are going to purchase one. Obviously, you're looking for the triple glazed one over the ordinary single glazed. There's also options for the auto fan switch off, so when you open the door, then the fan stops, which helps retain the heat. And you can also get ones with the exhaust preheat, which has got some good savings. So it's a useful list to be used, particularly in your induction training of the staff, and been able to label the pieces of equipment as well as to what their warm-up time is. But we'll go on to talk about the staff training later on. So just kind of pull out on the induction hobs. I mean, it is a considerably more efficient than the normal gas or even the electric. You can see we've got the electric gas, we've got the electric, then the gas, and then the induction heating. So there is a significant saving to be had there. Those prices are pretty general. I had a quick check on those yesterday. The induction hobs are more expensive. I think the general consensus in the industry is that you need to go for the commercial range on the induction hobs. The kind of smaller domestic ones aren't up to the job really, and don't last. But in terms of them being more expensive than the gas hob, yes, they can be, but I think over the lifetime of the equipment, you're going to make that back over a typical kind of 10 to 12 to 15 years of the equipment. There's also the aspect to reduce ventilation costs as well. If you're not using the gas, then your ventilation requirement is going to reduce as well. It's important then when we're talking about purchasing new equipment, you should be doing this with the energy running costs at the forefront. You're going to have this piece of equipment for 10, 12, 15 years or more. Those lifetime running costs are going to be considerable. They're going to be a hell of a lot more normally than the actual capital cost of the equipment. So this would apply to all the kitchen equipment, and the vast majority of them, you do have the option to go after more efficient pieces. There's a good example there. I touched on the gas-fired fryer, so you can see there those percentages aren't very clear, but you can see that compared to the upfront capital cost, the actual running costs of the fryer, including the oil, is significant. So it's going to pay you to go after the most efficient that you can. Wider kitchen services then, refrigeration, as we saw, was a significant load. I think compared to the other equipment, the actual load is smaller, but it runs all of the time. It's important to locate them well. The refrigeration and chilling, the important thing there is to minimize any heat gain, obviously. So you want to keep it away from the hobs or all of those sources of heat. The idea for refrigeration and chilling is to cool things. So you want to make sure that you don't lose that cooling easily. You'll see the infrared picture on the left-hand side shows you where the door seals on that walk-in freezer have gone. You've got the blue color there is indicating where the cold air is escaping. And also on the right-hand picture at the top there, you can see where the door to that refrigeration unit isn't even closing properly. So that's going to have to work a lot harder to maintain the desired temperature. So on the temperatures, it's also important not to overcool. If you're overcooling, then you're doing too much work on the refrigeration. So it's obviously for every degree below the minimum temperature that's required, there is an associated cost to that. So it pays to pay attention to this. Just check the seals. It's going to be obvious when the seals have gone, because you'll have icing in and around the doors, and where you have the walk-in freezers, then you would look to be fitting the heavy plastic curtains. A good indicator for especially the likes of the walk-in freezers where things aren't quite right. You'll see where things are beginning to ice up or to frost up as well. So you're looking there to be a regular defrost. The internal evaporators, they work at their best when they are free from the frost and the ice. That kind of icing can also be indicative of warm air ingress. You've got warm air will hold a lot more moisture, so when that gets chilled and cooled, the moisture drops out, and you can see there where you've got significant icing around the frame of the door. And I noticed that it doesn't have one of the curtains on it either, so that's not helping things. The external units as well, don't forget about those. You'll see the bottom right picture where that has become heavily soiled, so those should be kept as clean as possible. That's where the refrigeration unit is trying to get rid of the heat that it has extracted from the cold space. So in order for it to do that as efficiently as possible, those should be as clean as possible. So we've touched on this again, just to reinforce, think about the running costs. The running costs are going to be significantly more than the upfront capital cost. There are equipments on the enhanced capital allowances, so should check for those as well. And where I think often you would be purchasing the smaller kind of almost domestic scale refrigeration units as well. Obviously look for the AA energy rating on those. So with regards to the extraction from the kitchen, obviously it's you have to have it. If you have the gas in it, it's important to make sure that you're not over ventilating. So the rate at which you're extracting there needs to match the actual requirement. That requirement is going to be determined by how much cooking you're actually doing. The ventilation has to be on if the gas is on, but the rate at which that has to happen is allowed to vary. So some examples there, the picture top left shows you where the kitchen is over ventilating. That's the rate at which the air has been hauled out of the restaurant is holding open that swing door. So obviously there's the waste of the warm air being taken out of the restaurant area, and also the running costs of running the ventilation too hard. So the controls should be set them at actual demand. There's a couple of ways of doing that. You can see the ventilation control on the picture on the right hand side. There's a lot of variation there, so you should encourage staff to adjust the speeds according to the need. If they're not doing any cooking, then just turn the thing down. There's also a very good option, I've seen a number of these, is to fit an auto controller. This will recognize how much steam is rising into the canopy, and will then raise and lower the speed of the fan accordingly. There are some significant savings to be made there. Also, that that extraction, that exhaust that's been taken out, there is a lot of heat in that. So there are some nice little projects to look to recover that heat and use that to provide a portion of the hot water demand as well. You can see there the typical running costs of a standard ventilation unit. So there are some good savings to be made that can either be through, as I said, staff training to encourage them to turn it down, or to use the auto controller. Cost effectively, the auto controller is probably for the larger kitchen. I've seen them quite a bit in the likes of the larger restaurants, and I think a lot of hotel catering use them as well. So obviously the lighting in the kitchen, this is going to apply to the wider restaurant as well. If you haven't changed to LED lighting, then you need to get on with it. It's a well-proven technology. There's typical savings up to and beyond 70%. You're talking probably a project payback of 3.5 years. Remember that you want to change them out in the fridges and freezers as well. That'll reduce the heat gain because the heat coming off the LEDs is significantly less than the likes of the fluorescent lighting. Also in the areas where which are infrequently used, the likes of the stores or the walk-in freezers, then those lights should be automated. We've just given a quick highlight there of what the advantages of the LED lighting is. There's nothing to think about there. Just if you haven't changed to LED, then just get on with it. So looking at the wider washing equipment, as we've said, there's an opportunity there to produce the hot water requirement through heat recovery from the extraction, also heat recovery from the refrigeration units as well. As I said, those external units are trying to get rid of the heat that they have taken out of the refrigerated space. So there's an opportunity to use that to preheat water. Water saving devices, I mean, there's obviously the tap, the time controllers on the taps, flow restrictions and aerators to reduce the flow rate, and then the auto shut-off valves. Obviously, the less of the hot water that you use, then the lower the flow rate of the water, and obviously the less hot water that you require and the less energy you have to put into it to heat it. Some of the actual washers, a lot of those will have, a lot of the newer ones will have the option for heat recovery as well, which can make a considerable saving. So the likes of the heating, then the heating of the kitchen. I mean, often you're not wanting to heat it; you're trying to cool it. But I mean, often when I've gone in, you'll see that all the hobs are on and there's no cooking going on. You don't be using the catering equipment to provide your heat. There's use the actual heating that's installed. It's going to do it a lot more efficiently. Set the appropriate temperatures. Hot water should be no more than 60 degrees C. That's going to take care of the Legionella, and no one's going to get scalded. The internal environment for the kitchens, as we know, is hot. It's quite an active place as well. So you can keep the temperature to 16 degrees because there's a lot more. There's a lot of heat going into the space, and the people that are in it are usually quite active as well. It's good to look to control that internal temperature using thermostats, and you should check those on a regular basis. Similarly, for fitting the TRV valves on the radiators, that'll help give some kind of localized control. Not all the areas of the kitchen are going to be as warm as the others, so it depends on the function. So the likes of storerooms are going to be a lot cooler than the actual kitchen areas, or perhaps the prep areas as well. And again, as with all controls, they should be checked regularly and adjusted according to staff comfort. So in terms of the wider energy management, then it is an old adage that you can't control what you don't measure. So you need to understand how you're using the energy and when using the energy. Now we've given you that's a typical profile of hourly energy consumption, and that would typically be what you would expect. But you're only going to know if you're on that spectrum if you're actually monitoring what you're using. Now that doesn't have to be by the hour, but it can be if you're going to fit a smart meter, which I would encourage. But knowing what you use and when you use it means that you're able to benchmark against kind of sector performance. So being able to benchmark allows you to try and understand how you're performing compared to your competitors. So that can often help to drive change. Having the information to make staff aware of how much it is costing and where there is wastage as well. So where staff have improved and where they have gone through a little bit of training, then you can also use the information to demonstrate the impact that they can have on the wider profitability of the business. It can often be used to identify where you've faulty equipment, if there's consumption going on when you don't expect it, and being able to show where you have invested in efficient equipment, being able to show the difference that has made, and to quantify what that difference is it's often helpful to then justify other improvements. As I said, if it's a larger establishment, then maybe submetering could be used. Just depends on the cost effectiveness of that, but where you would look to maybe submeter the larger chillers or the cellar areas, or other smaller individual pieces of equipment as well. So we know that the kind of staff turnover in catering is high. It's staff intensive. So because there is that kind of throughput of staff, it's important that you carry out regular training and to keep doing it. You can't just train every kind of 6 months. It has to be a regular reminder to staff of what best practice in the kitchen looks like. So often handy to appoint an energy champion then who has responsibility, who has eyes and ears in the kitchen all the time. obviously you're wanting to encourage staff to follow best practice, but you need to inform them. I think the Carbon Trust did a lot of research on staff and behaviour, and we've found that the vast majority of staff want to help. They want to be environmentally responsible, but very often they don't know how to be. So the provision of checklists that we talked about at the beginning, that helps inform them of how they can help and what best practice looks like. Every kitchen is very individual, so you may have particular pieces of equipment that might warrant bespoke training on. The training should be included as part of the staff induction, shouldn't be overlooked. I think if you start off on the right foot, and I think it reinforces to the staff how important following best practice is to the business. As I said, the training needs to be continuous, and you should regularly audit to check how, or to try and understand the impact that the training has had. Part of the wider enabling of staff, as we talked about, you need to keep the staff up to date. That's where providing the information on daily, weekly, monthly energy consumption helps. And as we said, staff want to be environmentally responsible. So it would serve you well to to keep them informed as to the impact of their behaviour. So we talked about some checklists. Again, these aren't exhaustive, but they are useful. These give you kind of what best practice looks like against each individual piece of equipment, and we've kind of included some wider areas there, the likes of the overdoor heaters and the maybe the central heating boiler and external lights. But you can see it's all just sensible suggestion. There's nothing complicated there. One to highlight is the air conditioning. Often overused, often abused. In terms of the settings, the lowest you should cool to should be 23 degrees, and the highest you should be heating is 18 degrees. That allows what's known as a dead band in the air conditioning, which ensures that you don't have a unit heating and you don't have another unit that's cooling. They just spend their time trying to outdo one another as well. I'm going to talk about the lights there with regards to moving to LED as well, and the thermostatic radiator valves on the radiators. But I think fundamentally in a kitchen you're trying to get rid of heat rather than introduce it. Again, then just the sensible one was the glass washers. Don't be putting it on unless the thing's full, and some cellar cooling as well. Just some wider checklists. And then just some very simple ones for what best practice looks like for the cooking. There are wider checklists that are available in the Carbon Trust publications, which you can access through the website. These are pretty extensive, and they're up to date, and most of the information for this webinar has come from these, so you'll find the checklists are all in there as well. And there's some reports that we've done on the wider sector as well that you're free to access. And there's a little online tool there that will help you understand the impact from an environmental and a carbon point of view as to when you look to reduce your energy consumption. That can be useful, I think, to pull the information from that to use in your staff awareness and staff training as well. So look at the wider Green Business Fund services that we have available. They're available in England, Scotland and Wales. They're for ostensibly SMEs type businesses, but also include like schools and charities. There are some, there's the definition of an SME that will qualify for the free support that's offered. And some of that support includes, there's a series of workshops that we carry out around the UK, and they help businesses understand their energy consumption and then run to identify the top known low cost measures. The timetable for those are on the website as well, and you can register through the website as well. So you can see there's ones coming up in Swansea and Northampton as well. So across the UK. So the type of fund, or the type of support, we offer opportunity assessments. These can be remotely done over the phone, or for the larger organizations, we'll carry out a site audit, and we'll produce then a report that'll highlight and quantify the opportunities that are available. Should you decide then to move forward on the opportunities or on the recommendations, then we also offer some significant support to help you get comfortable with how to implement those projects. And we'll do all of the tender process and tender selection for you. Some of the other support we have then, there's the virtual energy manager. So it would look to highlight good practice. There's a half a dozen individual modules that are delivered over the course of that support. There's the technical webinars, which you're involved in one today, and as I'd highlighted, it's well worth, if you haven't already, get yourself registered with the Carbon Trust website. The access to the list of publications that we have is extensive and well worth having. So there's the other wider tools that are available under the Green Business Fund as well. I mean, everything that we are offering, or everything that we have done or have written or have published is all available from the website. So that's your first place to access it. Okay, we're at the end of the webinar. Thank you for listening, and I think Susan, we're going to have some questions.
Yes, so we've just got a few questions coming in. So one is, your checklist recommended gas appliances over electric. Even without induction technologies, isn't the rapidly falling carbon intensity of grid electricity going to call this into question over 10 to 15 year life of equipment bought today?
If you had a guarantee that the carbon intensity of the grid is going to continue to fall the way it is, it may well do. But I would suspect that the main driver for the catering industry is going to be cost. I think the gap between the cost of gas and the cost of electricity is going to be a much stronger driver than that.
Okay. How can we differentiate between two pieces of equipment that both display an A value for energy?
To be fair, why would you want to? If they are both A, then they're at the top of their game. I think it's going to come down to your own personal preference on perhaps manufacturer type, manufacturer name, or something like that. But I mean, if they're A-rated, then they're both equally meritorious.
Okay. Next one is, you gave a 15-year rule of thumb for replacing equipment. Does this
Yep.
rule include refrigeration equipment, or is this shorter?
Refrigeration equipment. No, I would say that was fine. The thing you need to watch for the refrigeration is the change in the refrigeration gases. I think that's being a big driver at the minute with regards to the equipment that you purchase. So probably with the refrigeration equipment, you need to keep an eye on the timetable for when they're going to be changing the refrigerants, or so that the ones with the lower GWP are preferred, I suppose, is the best way to put it.
Okay, another one.
Go.
Kitchen ventilation. Could you
No, yeah.
comment on the need for passive/active intake air, e.g. to reduce problems of warm air being taken from the seating area, as in your photo?
Yeah, that's a question about the wider kind of the wider HVAC in the kitchen. Yes, that's the comment is fair enough, that the only reason that the ventilation was having to haul the air from the seated area is because there wasn't enough ventilation in the kitchen area itself. But so there is a wider design issue there. But as I think the premise of the pictures is still valid. It's there just to highlight the importance of overventilating.
Okay, and we've got one more. The government is currently trying to decarbonize heat. Shouldn't this be taken into account regarding decision making over whether to buy electric or gas?
Well, I think that's to do with the electrification of domestic heat. We're talking about the use of gas for cooking as opposed to gas for heating.
I think that's all the questions we have, unless anyone has another question. Okay, so I guess we can wrap it up there. So thank you everyone for attending. As mentioned earlier, we will send out a copy of the slides to everyone for attending. So thanks very much.
Excellent. Thank you, Susan.